I will give you some examples how statistical programming can be written in Python. So I think all of you know this man. This is Van Rossum. He's a Dutch programmer, best known as the author of the Python programming language. And the interesting thing is that this Python is a very well-known language, and 27.93% users are there compared to other languages all over the world. And this right now, this Python programming is using in the various fields. Also, I mentioned in the previous session. Here, I specifically want to mention some of the package like NumPy, Pandas, Matplotlib, SciPy. These are the different packages. NumPy for the using a number or working with number in Python. Pandas for handling the data frame. As I told you that whenever we have data, we need to load that data in our Python frame, because if I have a data set, I need to work with the data set. So what code I need to write to handle this data set? That means how to read data from the data set, how to write data to the data set, how to manipulate all the data, and other operation related to data can be achieved by this Pandas package. It's a very essential and the popular package for handling data frame. Matplotlib, this is for the plotting purpose. Whenever we are trying to plot any kind of graphs in Python, we are using Matplotlib. SciPy is another package for in our Python. Scikit-learn and the stats model. These are the very good packages. Scikit-learn for the machine learning, and stats model for the statistical tools. So these are the interesting package. So I will show you the past how the stats package works. So this, as I told you in the previous session, that Python is very much popular, and we need to do a little bit of coding in Python that is fewer than the Java or C++. This is not a very new language. It was an old one. It in 1991 it was developed, but work started in the year of 1989. It became so much popular after the popularity of data science, and data science get popular after the invention of GPU, graphical processing unit. Now, this Python, whenever we are talking about the Python, the most interesting part of the Python is that it can automatically arrange the memory of a computer, because we all know that whenever we are using any programming language, there is a problem for allocating the memory space. Those are the programmers who have to arrange that how to use the memory space. In C, C++, Java, all other language, user has to decide how he or she wants to use that particular memory. That means, suppose I want to save 10 data in my memory. I need to find out where is the free memory space, how the data will be stored, and after using the data, after completion of working with the data, I need to free the location. Otherwise, that location will be blocked for forever. No other programmer will use that memory location that is occupied by the other programmers by saving some variables. So it is the programmer's duty to free the memory space. So this was the burden in case of C, C++, Java-like languages. But in case of Python, we do not need to bother about all these things. It will automatically perform dynamic memory locations, dynamic memory allocations, reallocation, like that. And here, in case of Python, it was that I told you that in late 1989, it was actually invented. Then when the Rossum was working, he was working on the lab. It's pronounced as Viscolu lab or Viscolu mathematics lab. So the most interesting thing in Python that here Python is an innovative one, and we are using Python worldwide. But the thing is that how the name came. A lot of people use the name Python, and editor's name called Anaconda. We use different editor in Python. One of the editor name is Anaconda. So it's written here. When this Gudio van Rossum was also working on Python, at that time he was also reading the book published by the BBC comedy series named Monty Python's Flying Circus. From there, he got inspired and given the name Python. Why companies prefer Python? Why we prefer Python? Because it is interactive. It's cell-based programming language. Suppose you have written 2 plus 2, and if you press enter, it will return back 4. So that means just like you are interactive after each and every line with the Python shell. It's interpreted one. What is interpreted and compiled? In case of programming language, if you written anything, the programming language has to convert your whatever you have written in English-like statement into the 1-0 format. So in case of interpreter, it performs translation line by line. And for compiler, it takes the whole code and it converts the whole code into the machine learning or machine level language as a single shot. So compiler is a machine dependent. Interpreter is not machine dependent. That's why it's platform independent. And it's modular in nature, dynamic in nature. It's also portable language. Here, these are the giants company presently using this Python, right? So when we are using Python, we need to, these are the more companies who are using Python. That's why I'm saying or emphasizing that Python is so much popular. These are the top companies using Python. So look at the number of companies using Python. As I told you, it's easy to use, expressive one, modular approach. What do you mean by modular approach? Suppose you are writing any program. Instead of writing the whole program in a single function or single module, you can split that one. What is the advantage of this? You can modify, you can delete, you can change any kind of module without hampering the other modules. So this is the modular programming approach, where this is called bottom-up approach. That means you can build several modules. After gathering all the modules, now you can build the top model. Different advantages are there, but disadvantages are also there. Speed, because you need a high-end processor to compute a lot of data. It takes a lot of memory for processing a lot of information. Maybe there may be a problem of runtime errors in Python. So I have gave you the example of compiler and interpreter like that. And now, what is Python distribution? So now we are moving to the section where we need to see some Python codes. So before that, the question comes here, where you will write the code and what are the Python distributions are available. So a Python distribution means it's a software. It's a bundle of software which contains a Python interpreter. As I told you, Python will interpret whatever you have written in your English-like language. It will interpret into machine level language so that machine can understand and processor will process that one. Again, processor will give you the result in machine level and interpreter will convert to the high level so that we, the people, can understand the language. We, the human beings, can understand. So it's an interpreted one, and Python is some standard library. So C Python distribution is a standard one distribution. So this is the official version of the Python known as C Python. You can download in python.org site. It's called C Python. And it comes with several packages. If you want some package extra that is not already installed, then you can easily install that package in Python. So this is active Python. This is one of the editor, or rather than I can say the distribution, you can download, okay, and work. Anaconda is another distribution you can download, you can work with. This Canopy is another one. WinPython, this for Python for Windows. What is IDE? IDE means integrated development environment. It's a software applications. It gives you the essence of GUI. Means when you are writing any program in Python, so you have to write the program in shell. If you write and enter, it will give you the result. But if you want to experience the GUI interface, the graphical user interface, then you can install IDE. So there are a lot of IDEs are there. So here, this is the Ninja, Spider. Eclipse is the most useful library. In case of Java also, we use Eclipse. Then Django. Django is very much popular. If you want to design any website using Python, so Python is not basically for analyzing or for generating some graphs, not like that. Using Python, you can also develop your own website. So basically, you know that previously we are using Java server pages, JSP, or maybe ASP, active server pages from Microsoft. We're using this kind of languages, this kind of scripting languages for designing our websites. But right now, Django is very popular. That is Python-powered web technology. So in web technology also, we can use Python language. So one for every solution is Python. This is SpyScripter. This is another ID. It's called Beware, Coders Diaries, Eric, Xcoder. So these are the different ID you can use. Not only people say that only I have Anaconda, or maybe I have something else. So you can use all this ID also. PyCharm, PC is most useful one. PC is called PyCharm. Jupyter Notebook. I think all of you know that. Those who are writing Python programs, maybe you are using Jupyter Notebook. Okay, this is Commode, PyDev, PySites. Okay, so RubyMine is another, Rodeo is another option. These are the ID. We have a lot of Python editors also. This is Python editor, Commode editor, Emacs editor, where you can write your code. This is Edit, Atom, Bedit, Bluefish, Editra, Leo, Notepad++. It's a very good one. Here you can write a program for another programming language also. Sublime, Vim, TextMate, TextWrangler. So these are the different options are available for IDE. Okay. Now here I want to give you the essence that how easy to write any statistical testing code in Python. Look at here. Here we are concentrating different statistical testing. Suppose we are concentrating on, this is normality test. Okay. So in normality test, as I told you, for any kind of hypothesis, what we need to do? We need to specify the null hypothesis H0 and the alternate hypothesis H1. So here H0 is the sample has a Gaussian distribution. This is my null hypothesis, right? And H1 means the sample does not have a Gaussian distribution. This is my alternate hypothesis, right? Now, if I write program in Python, then look at the program. We actually try to import this particular test. The test is Sapiro will test. So I have a package, I have told you, it's called stats package. So from scipy.stats, this is my package name. From this package, please give me this particular function. This is Shapiro function. This function is already written in this particular stats library. I do not need to know how it is written. What is the logic behind this function? As a programmer, I can use that function directly. That is the most usefulness of Python. If it was C, you need to write the whole logic or code by yourself. So here I have specified, suppose data equals to this much of data. I have this much of data. This is my data set. Instead of specifying data using pandas package, also, right? So suppose you have thousand data. And comma separated notation. So what you can do, you can import that particular data set containing thousand data with the help of pandas package. Now, here we are, what I'm doing, I'm calling this particular function. Look at the actual code of Python. This is this amount of code you need to write. Whatever I have highlighted, Shapiro is my function name, and whatever the data I have specified, I have saved all the data in this data variable. I have passed the data variable as an argument of this function. And now the Shapiro function will take the data. All the operations will be performed on this data. Where? In this stats library. In this stats library, the code is written. So data will be moved to that stats library. Operation will be performed there. I do not need to know any line of code, what is happening there. After execution of that, it will give us two results. It will return two arguments. We programmers used to say two arguments or two parameters. Now we need to catch these two parameters. So this particular thing is called function calling, or rather, the good name is called method calling. The Shapiro is a method. I'm calling the Shapiro. Shapiro, please come and take my data. It will take my data and it will process the data and it will return me some results. It will return, for this Shapiro function, it will return two results. How many results it's going to return? It's depend on how the function was written. If the function was written like that, suppose I have written one function called addition. I have added two number. If I added two number, what will be the result? The result will be one single number. So I will only get one number. If I add 5 plus 4, I will get 9. So I will get only one number, 9. So this addition function will return only a single number, just 9. The same case here, if Shapiro wants to return two variables, two results, so I need to catch these two results. So here I am actually receiving the result that is returned by the Shapiro function after working on the data. And this first data is saved on stat and the second data is saved on P. You can use any name here. You can use here A1, A2, X, Y, whatever the name you want, you can specify here, right? Now it's a time to print whatever I got, because Shapiro has given two values. It was saved in stat and P. Now it's time to print the value on the screen. So it will print the value. It will print the value. But whenever it will print the value, I'm specifying how many point value will be there. Look at the results. If I think it's visible, I think if I magnify, I think it's visible. It will return the value, and if I want to see the result, three numbers after floating point, then I have to specify 0.3f. If I want to see 5 numbers after point, then I have to specify 0.5f, like that. Okay. So here 0.3f is specified. So the results is look like 0.895 is the result. Here, if I specify 0.22f, then the result should be like that 0.89. Okay. So whenever we are getting the result, we are checking here whether my p-value is greater than 0.05. Whether p-value is greater than 0.05. If it is true, then it will print probably Gaussian, else it will print probably not Gaussian. I think you know that in Python programming, we are actually performing indentation. Look at here. If then this printf is written using indent, that means printf statement is under the if statement. Same thing here. This last print statement is under this else statement. So here, look at here, like your Shapiro, the print is also a function. Print is also a function or method. Method or function can be specified using first brackets. That means parenthesis open and close. Look at this parenthesis, first bracket open, first bracket close. What is the similarity between Shapiro and the print? Both are the functions. The similarity are like that. In Shapiro, I have passed this data. I have given data to the Shapiro function. Here, in print function, I have given this probably Gaussian, this particular data as an input to the print function. So print function will receive this particular string or this particular sentence, and it will work with this sentence so that the sentence can be printed on your screen. So look at simply, if you use C language, C++ language, I think you have heard about this print statement. In C, it was called printf. So here, we do not need to write the code that this way you print this particular statement on the screen. No. How the statement will be printed on the screen is already written in the print function. What I am doing, I am using the print function, just like that. So this is the power of Python programming language, that within these 2-3 lines, we can complete our program and we can get the result, right? So I think you get the essence. And same thing here also. If I perform any test, take any test and try to compare what I have told you right now. The previous example. In previous example, I have worked with one test. So that's why in import, after import, I have mentioned the name of the test that I need to perform. Here also, I need to perform this normal test. So I need to mention here, I need to import the normal test. So please give me the normal test. Please include this normal test with my program, right? So it will again call the normal test with the data, and it will print the data, and the result is actually on the screen. In this way, we can perform any statistical testing, just calling the function. That's all for us. Okay. So here, the interesting thing is that how many codes are written? If I count 1, 2, 3, 4, 5, 6, 7, 8, you are thinking that my program has only 8 code. So my interpreter has to translate this 8 high-level statement. Why I'm calling it high-level statement? Because it is written mostly in English language. So my interpreter should have to convert this 8-line English-like statement to the binary language, means 1-0 language, machine-level language. No. Here, instead of converting these 8 lines, the interpreter has to convert much more lines. Why? Because I have given here import normal test. How the normal test function will be added with your program, something written there, and it's hide to you, so you are not getting the complexity. Normal test function has the logic how to perform normal test on the given data. So that code is already written in the stats library. That code also going to be attached in your program, right? So these are the attachment. These are the extra code. These are not available here. But whenever you are running this program, this will be automatically added to your program. Now your program will be 40, 50 lines programs. So now your program will be similar to the C program. If you write the same code in C, it took 40 or 50 lines. But here, without bothering all the complexity of the code, you have written this program using 7 to 8 lines. That's all. But the interpreter has to translate this 40 to 50 lines code to the low level language, means machine level language, and then after that the interpreter will process that one. Okay, so I'm trying to say that Python is trying to hide the complexity from its user. Python trying to present the language in such a way so that user can write their things, write their logic very simply, and rest of the work will be performed by the Python itself. So that's why Python is popular. If you consider Anderson-Darling test, look at the line of code here written. Look at here, same thing. Anderson, this particular function should be imported. Look at here, I've imported that particular package. This is called package. In that package, this function is written. Okay. Generally, packages consist of some classes. Classes means collection of methods and collection of data, collection of functions and data. So here, Anderson function is again called. Again, I have specified the format. This time, if I need to print in this fashion, multiple lines, I need to perform iteration. That means using for loop. The for loop will be executed and each and every statement going to be printed. Okay. So this is the logic how you want to get the output. This way you need to perform this. In case of Pearson correlation coefficient, look at here. In case of Pearson correlation coefficient, you need two data sets. So that's why you have specified two data, or data 1, data 2. As I told you, you can hear pandas package also to get the actual data. In actual cases, data will be very much high. You need to work with lot of data. Then you can use pandas package. Here also, this Pearson function, look at the spelling. Look at the spelling. In Python, you will get error if you mistakenly written here Pearson. No, it's Pearson R. So you need to minutely check the spelling. Data 1, data 2. These two data are specified. Data 1 is the first array. Data 2 is the second array. Array means collection of this number. So this data 1 and data 2 is actually two arguments. Previously, in two previous cases, we have seen that we are only just transferring data. Means we are only transferring one array. But here, we need to transfer two array to perform the Pearson test. That's why data 1, data 2 are the two arguments of this function, right? And here also, two arguments get written, and we have saved that argument like previous stat, p, and now after certain checking, if the p value is greater than 0.05, if this condition gets satisfied, then probability independent will be printed. Otherwise probably dependent will be printed. Okay, so this much of easier the Python code is. Simple. If you consider the next one, Spearman's rank correlation, here also look at the same thing. Same thing. What is the difference between the earlier code and this code? Can you tell me? What is the difference between this code and this code? Look at here. That's why I'm saying you a lot of times. In case of correlation test, whatever the code you have written, and in case of Spearman's rank correlation test, whatever the code I have written, exactly identical except the function calling. In there, the name was Pearson R. Here, this is Spearman R. Just this line, these two lines, one line and the import line, two lines. The rest of the codes are same. If you use the same data set, you can use the same data set or the data set also. Data one, if you data one, data two, you can use the same data. But with these minimal changes, you can write another level of code for test your data. So that's the beauty of Python programming.
So can you explain that print code? Print stats 0 colon then
Yes, yes,
0.33.
yes. It's been that's why I have told you previously that when this stat variable will be printed, look at here, it will be printed like this. That means from 0. That means here, starting from 0. Suppose if I print here 0.85, it's same as 0.85, right? 0.85 is same like 0.85. But I want to print the result in this format, that first of all, this position should be 0. This whole number position should be 0. Otherwise, if I don't specify this, suppose I don't specify this, what will happen? It will print 0.85 or 0.8 simply. So how many digits I want to consider before and after floating point, I need to specify this. Okay. So I need to specify all these things. Otherwise, it will get problem. So here also, if I specify 3, that means 3 digits will be there after the point. So 855, these 3 digits are there after the point, right? And 0 is here. Look at here also. Here, what we have done, same thing we have done. 0.688. Here we have done 0 should be there. Look at there, 0. And after point, how many digits will be there? 3 digits will be there. So 3F, F for floating point. 3 floating point number will be there. 3 floating point digit will be there. Clear?
So what is G then for? If
Oh,
F is for floating?
that was mistakenly written. It should be
Oh,
F.
achha,
It should be F.
okay, okay.
Okay. Next, chi-square test and all these things. Now I'm moving to the next part. Then I will explain all this chi-square test and other tests also. Now, in case of hypothesis testing, as I mentioned to you, that in case of jet test, now how to perform the jet test? Because in parametric test, I have given you in the previous session the name of the parametric test and the name of the non-parametric test. But I haven't yet discussed about this test in detail. So now it's time to discuss about the details of jet test or other parametric test, and then we will see the Python code of that. So if I consider 1,000 people, and if we consider literacy and illiteracy topic, then if I say that 200 people are literate out of 1,000 people and 800 people are illiterate out of these 1,000 people, then easily we can consider that if P is 200 and Q is suppose 800, then P plus Q is the whole thing, whole number 1,000. So how can I say that? P means, if I consider the ratio, 200 divided by 1,000 is 0.2, 20%, and this is 800 divided by 1,000, 80%. If I add this 0.2 plus 0.8, it will give me 1. So now P is 1 minus Q, or Q is 1 minus P, simply. So here, this is the formula to calculate the Z test. Okay. So first of all, Z equals to X minus NP whole divided by root over NPQ. Okay. And Z, this first thing, this first formula, whatever I have told you, is for test for number of successes. And this is the second formula or second techniques in Z test. This test is dedicated for testing the proportion of successes. And third one is for test for difference between proportions. There are 3 different tests under this Z test. For last 2 tests, test for proportion of successes, you need 2 samples. And for difference between proportions, for this test, you need 2 samples. But for the first one, you need 1 sample. So right now I'm giving you the example of first one. Okay. So consider this example, the question 1 written here. A coin was tossed 484 times and head turned up to 65 times. Test the hypothesis that the coin is unbiased. Here, there is no significance level one mentioned. So I have taken 5% level of significance. Look at this table. If it's 5% level of significance, then what will be the two-tail test and what will be the one-tail test value? And here, initially, using the formula, that first of all, I have to design my null hypothesis. So what is my null hypothesis here? Number of heads equals to number of tails, right? It is my null hypothesis. And what is my, so because I'm considering this is the unbiased coin. So what is my alternative hypothesis? HA, number of heads not equals to number of tails. It will oppose to the null hypothesis. Now, if I put here what are given to us, n equals to 484, right? 484 times it was tossed. Now x equals to 265. This is my case. P equals to probability of head is 50%. Probability of tail is again 50% because it is unbiased coin. So now if I calculate the Z value, look at the Z formula. X minus NP whole divided by root over NPQ. Now if I put all the values, I will end up with the result 2.01. This is called Z calculated value. Whatever the value I have got from this calculation, 2.01, right? And in this table, in the two-tail test, the value is 1.96, right? Now 1.96 specify that what is the range? Means the range to accept this value is minus 1.96 to plus 1.96. And what is my value? 2.01. Is 2.0 falls between this minus 1.96 to plus 1.96? No. So coin is biased and the null hypothesis is not accepted. So we will accept the alternate hypothesis. Okay. So same thing. If I consider another example of dice, if a dice throws for 256 times and here odd points appeared 122 times, would you say that the dice is fair? So here, if I consider that what is my my hypothesis, number of odd numbers equals to number of even numbers. In dice, what are the odd numbers? 1, 3, 5. What are the even numbers? 2, 4, 6. Both will be same, right? So this is my null hypothesis. What is my alternate hypothesis? It should not be equals to, right? Now, whatever the data is given to me here, odd means 1, 3, 5. Even means 2, 4, 6. So there is a probability. This is 3 numbers out of 6, 3 number out of 6. So there is a 50% of probability. Here, if I put the value in that particular formula, I will get calculated as minus 0.75, right? I'll look at the range is 1.96. So minus 1.96 to 0.1596. Whether this minus 0.75 falls under this. If it falls under this, yes, it's fall under this particular range, so it's accepted. So my null hypothesis is accepted. So this is the way we can calculate the Z test. Similarly for the next also. So in a hospital, there are 960 female and 1040 male. Babies were born in a year. Do this figure confirm the hypothesis test? So look at here, whatever the calculation we are doing, whatever the formula I have told you, using this formula, the function is written in this Python library, right? So what we need to give, look at here. What are my parameter? In my previous coding example, I have given you that data to that particular function. So I have gave you the example that there may be a function which can take one argument, means simple data. There is a function that can take 2 arguments. In case of Pearson test, we have passed data 1 and data 2, 2 arguments. So how many arguments you need to pass? The number of argument or number of values, variables required to perform your test. Look at here. In case of Z test, what are the values? You need X, N, P, Q. These are the values you need. So how many variables you are going to pass in Z test? This much of variables you are going to pass. After receiving all these variable, the Z test function that is written in the stat library, what it will do? It will simply use this formula to calculate the value and it will return the value. When it is returning the value, what we are doing? We are saving the value like previous one, stat and p. We are saving the value, right? And we are printing the value on the screen. So this is the logic. Using this logic, we need to write the code. If we need to write code in C or C++, but if in Python, if for Python, we do not need to write. We need to just use the function. So look at here. If I consider this particular program, if I want to generate some value, look at here. I have told you NumPy is a package used for generating number, right? So look at here, from NumPy dot random import seed. What does it mean? NumPy is my package name. Random is a function, which, or rather we can say package or class. I think you may get confused. Class means in random, all the functions and data are there. If I want to work with random function, then I need to call the random class. In random class, random function is there. Look at here. This is my random function. Okay. What is the name of the random function? RANDN. RANDN is the function name. Where this function actually reside? This under this random class. Okay. So under this random class, there is a function called RANDN. And some data are also there. Which data? Seed value. What do you mean by seed value? Suppose if I ask you to generate number within 100, then how will you generate random number within 100? If I ask you to generate 5 number within 100, so you should have a logic to generate some random number, right? So this random function has that logic to generate some random number. But what happened if I run this random function several times? The same logic going to be executed and you will get same set of random numbers. Suppose in the first iteration, the random function gave you 10, 20, 30, 40. These 4 numbers to you, 10, 20, 30, 40. You may ask that, you could have asked me that, how this number get generated? I can tell you that there is a logic. Using that logic, they have generated some number within 1 to 100 range. If I run the program again, the same logic going to be executed. Again, the same 10, 20, 30, 40 will be generated. If I run again, it will again generate 10, 20, 30, 40. What is the problem? Problem is this, every time it will generate the same number, right? Have you got my point? So what to do? There's a concept of seed, SWD, seed. Using this seed, what you can do, each time you can use different seed value for your logic. Suppose in your logic, you have written that I'm starting with a number and I'm doing some operation on that number, then only I will generate some random numbers. So you need to start with some number. So if you start with same number for every iteration, so it is the case that it will generate the same 10, 20, 30, 40 for all the iterations. That's why if you use different numbers as a seed value for different iteration, so in different iteration, it will generate different random numbers. That's why I am calling this seed, and here I'm specifying seed within first bracket 1. And maybe in next iteration, I may specify seed within bracket 0, seed within bracket 5. So I can pass different seed. So here, seed is a function, right? It helps me to generate the random numbers. Next, numpy.random import randdn. This randdn is a function which actually generates your random number using this seed value. Again, I'm importing mean function and standard deviation. Look at here, std, standard deviation. Where from I getting all these things? From NumPy package. You could ask me, sir, you have told me that I need to use stat package to do all these things. Yes, if you want to perform the high level activities like different kind of test or different kind of high level activities of statistics, you need dedicated statistics package. But this numpy package is the package which deals with number. It actually give you the essence of simple statistical tools like standard deviation, variance, mean, median, mode, like that, correlation. Okay, so using numpy package, you can perform all these things. So here, what you have done, you have used here some function, some logic to generate some data. Here also you have used some logic to generate some data. This logic is depend on you. It's random in nature, how you are generating some data for you. You have generated two data. And now what you are doing, you're calculating the mean of the data one and standard deviation of data one. Look at here, we're printing all these things, right? So it will print the information. Look at the information. It has printed the information on the screen. Mean is this, standard deviation is this. It's a simple code of Python for doing any statistical operation, right? If you copy paste the code, it will run. If you change, if you want to perform mode, import mode. If you want to perform median, import median. Same code will run. Okay. Now, next is student t-test. So this is another parametric test, student t-tests. So this was actually invented by Gossett, and he gave the name student t-test. So here, this t curve, the range of this t curve is actually from minus infinity to plus infinity. It will not touch the x-axis. Look at here. It will not touch the x-axis. It is minus infinity to plus infinity, right? And in case of, it has a bell shape like the normal distribution curve, but it is smaller amplitude than, it has a smaller amplitude than the normal distribution curve. Okay. Here, look at this example. Here, some values are specified. N values are specified. 5, 10, 30, infinity. These are the n values, sample sizes. Okay. And this is the new. New means n minus 1, samples minus 1. This is samples minus 1. Okay. And is the t value of support 0.01. Okay. So if my sample size is n equals to 10, this will be my graph will be look like this. So this t distribution can be useful when the n value is less than 30, strictly less than 30. Look at here, after 30, it will be infinite in nature. Then we need to need z-test. Okay. So here, if I consider any example, maybe then we need to consider this p-value, significance level, two-tail test or one-tail test. I can go with either two-tail or one-tail test. Now, from the t-table, we can find out what is my range and whether my value is under this range or not. Then we can say that, okay, my hypothesis is accepted, like the previous one, z-test. Now, in case of student test, I have told you this example. What is paired t-test? What is unpaired t-test? In case of paired test, we are using same dependent things, dependent variables. In case of unpaired, we are using independent variables. Now, if I take this example, simple example, look at the problem statement. The manufacturer of a certain make of thermometer claims that his thermometer have a mean life of 20 months. A random sample of 7 such thermometers gave the following values. Life of thermometers in month, 19, 21, 25, 16, like that. I need to find out, can you regard the producer's claim to be valid at 1% level of significance? Why I am giving you this problem statement, so that you can be able to understand that in which cases, which particular test case is applicable. So here, this is the formula. T equals to mod x bar minus mu into root over n divided by s. Okay, here s is the sample deviation, sample standard deviation. So look at here, this is my x value, what is given in my problem. I have calculated x minus x bar. then x minus x bar whole square. Okay, I've calculated the new means n minus 1. Okay, and if I put all the variables in this formula, then I will get the result. Okay, so this is 0.716 t calculated. And look at here, what was my hypothesis? Mu equals to x bar. And what was my alternate hypothesis? Mu equals to mu not equals to x bar. So I've calculated the value of t. Now I have to validate the value. From the, I have to compare the value that I have calculated with the table value. So in 0.01 significance, what should be the value or table value? Okay, so look at here. In 0.01 significance, this is what is this? This is 6 new. What is the meaning of new? New means n minus 1, number of samples minus 1, right? This is 6. So that's why from this table, t table, I'm getting this 6 here and 0.0 point here, 0.01 from here, and the intersection point is this 3.707, right? So this 3.707. So the value calculated is falls under this plus 3.707 to minus 3.707. Yes. So H0 means the null hypothesis is accepted, that designate that mu equals to x bar. Okay. And this is ANOVA. This is called analysis of variance, and widely used tools, parametric test tools. In case of ANOVA, if you consider this analysis of variance tools, then these are the different samples, maybe taken from the same population, maybe taken from the different populations. Okay, so these are the different samples, x1, x2, x3, and this is the mean of this sample. Look at the dotted line, x1 bar, x2 bar, and x3 bar. And if I plot my graph like this, then it says that all these are the subsamples of this population, that the universal population. So I have taken, this is my samples from this population, right? So x1 bar, x2 bar, x3 bar are the mean of each and every samples. Now, what ANOVA will do? ANOVA will compare the global mean with the local mean. What do you mean by global mean? The mean of the population. As I mentioned earlier, whenever you are using parametric test, you should have the value of mean of the population, whole population. So here, the whole population mean is very much important, right? And then we need to figure out the difference between the global mean and each of the local mean. Look at here, for this sample, A is the difference between global means and the local mean. B is the difference between this. In this way, if I use ANOVA, what is the formula? The formula is variability between the means whole divided by variability within the distribution. Okay, so here, this is the steps how you can calculate. So here I have taken the first step, that is H0, means the null hypothesis is mu1 equals to mu2 equals to mu3. That means all the mean are same with the population mean. And here, this is a case that mean are not same. This is my alternate hypothesis. Okay. Now, this is the example. If I solve that example, you will be able to understand how ANOVA works. I have given you the classification that there may be one-way ANOVA, two-way ANOVA, three-way ANOVA, and multi-way ANOVA. But here I will give you only one example of one-way ANOVA, so that you can get how the essence of ANOVA, how it works actually. So look at the problem statement. To assess the significance of possible variation in performance in a certain test between the schools of a city, a common test was given to a number of students taken at random from the 12th class of the three schools concerned. The result given below. Look at here, ABC are the three different schools. Okay. So make the analysis of variance for the given data. Now, these are my steps. Look at my problem. This is my table. Okay. So here, what is my hypothesis? Hypothesis means the mean of this A, mean of B, mean of C will be all same. And what is my alternate hypothesis? All the means will be different, right? So if I calculate 6 plus 4 is 10 plus 2 is 12. So 12 is here, right? If I calculate the mean, then 12 divided by how much? 3, because 3 samples are there. So 12 divided by 3 is 4. Same like xb equals to 15 divided by 3. This is 5. Xc bar equals to 18 divided by 3 is 6. So I got mean of each and every school. Now what to perform? Look at that. Point number A, calculate of mean of each sample. So I have calculated. Number B, calculation of grand average of means. Grand average of means means, what does it mean? Try to add all the means divided by 3, because there are 3 schools. So xa bar plus xb bar plus xc bar whole divided by 3. So it will give me 5, right? So now next one, calculation of the SSC means sum of square between samples. Now how to perform these particular things? Look at here. The calculation of sum of square between samples. So this is the formula. This is the formula that xa bar minus x double bar means this is a global mean. So 4 minus 5 equals to minus 1, 4 minus 5 equals to minus 1. In this way, you need to calculate all these things, right? And you need to take the summation and then whole square. So if you add 1, 1, 1, it will be 3 after taking the summation. If you add this 0, 0, 0, it will be 0. If you add 1, 1, 1, it will be 3. So if we add all these things, it will be 6. So 6 is your sum of square between samples. Now, what will happen in this case? Look at here. So I have written 6 here, right? Next one, calculate the variance within the sample. Calculate of SSC sum of square within samples. So the previous one was sum of square between samples, and this is sum of square within sample. So here I have mentioned how to calculate the sum of square within sample. From there I got the result of 24, and I have mentioned there this is 24, right? And finally I need to calculate the ratio of F. So how to calculate the ratio of F? F means MSC by MSC, right? Now if you look at here, this SSC is 6, new one is C minus 1 means population minus 1. This is the degree of freedom. That is 3 minus 1. Total number of samples was 3. So 3 minus 1 equals to 2. So what is the MSC? MSC is SSC by C, means mean sum of square. MSC means mean sum of squares. This is SSC by C minus 1. So 6 minus 2 equals to 3. So now here we got 3 here. So now F equals to MSC by MSC. Now in the next row, I can calculate MSC is 4. So if I calculate 3 by 4, it will give me 0.75. So this 0.75 I got as F value, right? This is my calculated F value. And now I need to find out what is the tabular F value. And if the tabular F value, this value is greater than this one, then H0 is accepted. That means if the calculated F value is less than the tabulated one, then this H0 is accepted. Simple the case. This is a tabular form, and here I need to find out the value, tabulate value of this F. If I get that value, then I can compare whether it is acceptable or not, right? So this is the way I can work with parametric, all the parametric test. Now, here, if I consider non-parametric test, so this is the one example of non-parametric test. It's called Wilcoxon signed rank test. Now, here, this signed rank test, this non-parametric test is actually categorized into 2 classes. One is called signed rank test, and this is called rank sum test. This Wilcoxon is a signed rank test. These are the formula. J equals to this, mean equals to this, standard deviation equals to this. These are the different formula to calculate the Wilcoxon signed rank test. Now, suppose this is the question. A drug is given to 11 patients, and difference in their BP were recorded to be, this is the difference before drag A, before pushing the drug, and after pushing the drug. Okay. So you need to find out, is there any relation between the blood pressure rises with this drug? So use the Wilkinson signed rank test to test the hypothesis that the drug has no effect on change of BP. Okay. So here, if I consider the table, then we know that these are the formula, J, mean, standard deviation. These are the different formula. Now, what we can do here? Here, before we have these two values, before drag A and after drag A. Now, here, I can perform this operation. This is difference. We can perform this difference. Any differences, we can take the mod difference also. 160 minus 112. So what is the difference between BP? If I take all these things, then I can take the mod of this. Okay, I can take the mod of this. Then what is R? R means rank. Look at here, it's called rank test. So I need to put rank here. Look at here, what is the minimum value here? Minimum value is 1. There is 2, 1 here. 2, 1 are the candidate for the minimum value. Then I can't give rank 1 here, 1 here. So there are two values. How to resolve these things? What we can do? We can give this is rank 1.5. This is rank 1.5, like that. Okay. So next value is 2. So this I have given 2 values rank. So this is 3, third rank. Okay. This is the rank number 3, third rank. Now, after that, I need to find out next value. Next value is again 3. Next value is again 3, right? So I need to find out that for this, I need to put the rank. This is 4. So in this way, I can specify the rank, and then I can find out this way that R positive. What does it mean? Means the rank corresponding negative numbers. Look at here. For this rank 5, there is a negative number for -4. So we will add all the positive number corresponding, all the positive D values for the rank, positive rank, and all the negative D values for the negative rank. We'll get R plus and R minus, right? So now we can calculate the standard deviation, because all the values N are here. N means 10 because there are 10 samples. What is the mean? Mean formula is here, N into N plus 1 by 4. So this is the formula, 10 into 10 plus 1 by 4. I can get the result here. I can get the standard deviation here. Now what is the formula of Z? R minus mean divided by standard deviation, right? I have 2R, R positive, R negative. So I can try out with these two. So first of all, I have tried out with the R negative. I got the result 0.255. If I try out with R negative, we also get the result 0.255, right? So this is the calculated value, 0.255, calculated value. And now we need to consider what is that table value. For 0.01 significance, the table value is 2.58. For 0.05 significance, the table value is 1.96. If table value is greater than this particular things, calculated value, then it is accepted. So this is a code or this particular science rank test. Look at the code here. Same thing like the previous one. I have used name numpy here for inputting the seed value. I have used numpy here for inputting the random function. SciPy stats, look at here. This is the special function. It's not an ordinary one like mean, median, mode. So it's not available in the numpy. That's why I have used the special package called stats for this particular special test. So from this stats package, I have imported Wilkinson, and then using the data 1, data 2, I have generated the I have get the data and fitted the data in that particular function. Look at here. I think now you are get familiar that all the codes that I have given you are very much similar. Only what you need to change, you need to change the name of that particular test, right? And you need to check how many arguments that particular function required. So next test is called Mann-Whitney-U test. This is another non-parametric test. Okay. So this Mann-Whitney-U test is actually for the unpaired data. Okay. It's a non-parametric test popularly used for the unpaired data. And these are the formula. Z equals to U equals to U given here. This formula is if the value is n1 less than n2. Here, for this test, we need to consider two sets, A and B. If I'm considering the total number of data available in A, means the total samples available in A is less than the total number of samples available in B, then we can use this particular formula of U. Otherwise, we need to use this particular formula of U when n1 greater than n2. So in case of A, 75, 80, 90, this, suppose these are the value. Okay. So total there are n1 value is 3. So 3 samples are there. Suppose for B, 4 samples are there. One interesting thing is here that in the previous case, we have given the number, given the rank, right, for the D values. Here also we are providing the rank, but whenever we are providing the rank in this Mann-Whitney-U test, what we are doing, we are providing the rank by considering both of the samples. That means we are trying to find out which one is the least number between these two samples. This is 35. So 35 becomes 1, right? And then 60 become 2. In this way, we can put the rank. So consider this particular maths. Students of same class are studying into different section, A and B. 6 students from section A and 8 students from section B are given a test. The marks obtained by them are given below. So this is the section A marks, this is section B marks, right? So how many students are there? 1, 2, 3, 4, 5, 6. And here 1, 2, 3, 4, 5, 6, 7, 8. So 6 less than 8. That means n1 less than n2. So we need to use this formula. Okay, this U formula. So if I perform the test here, then what will happen? We need to find out the R1 and R2. Now for this particular things, find out the R1, this is my rank 1, and this is for the rank 2. Okay, this is for the rank 2, and we are giving the rank considering both the elements, both sets element. Okay, so here A0 equals to, what is my assumption? That average marks of this section A should be equals to the average marks of section B. It should be the assumption or your null hypothesis, and the alternate hypothesis is that the average mark of these two sections should be different. Now, what will happen here? We are calculating all these things. That is, we need to calculate Z. So first of all, what we need to calculate the standard deviation, SD, right? Mean, U. These 3 things we need to calculate. So first of all, I'm calculating U using the variables available to me. Okay. And then we're calculating mean, standard deviation, and then all the value to the for calculating, we are putting all the value in this formula for calculating the Z, and we are getting the Z value as 2.77. This is called Z calculated. I think now you are familiar with this type of calculations. Now we need to find out the table value of Z for the significance of 0.05. Now table value is 1.96. From the table we can get the value, and we can say that this A0 cannot be accepted because the tabular value is greater than the table value. So it's outside of the range. Here also, if I consider the Python code for this particular test, look at here. What is the change here? What is the change here? Same thing, only the function name. Mean white U. This is the function name, right? So we have imported this function particular class, and under this class, this function is there. And we are calling this particular function using 2 data set, same as previous, right? So the code is very simple. This is the Kruskal-Wallis test, H test, and Kruskal-Wallis test, or anyone can say that this is called H test. This is the alternative to the ANOVA. I've told you that ANOVA is a very popular test and it is parametric test. But whenever you are performing non-parametric test, then it is similar to the ANOVA. What ANOVA was doing, ANOVA was comparing the mean differences from the global mean to the local mean. Here also, H test give you the essence of ANOVA. Here the formula is written, H equals to this, right? So now, if we consider this particular example, then particular, suppose you need to take some vaccines, X shield vaccine, Yo vaccine, Zovax vaccine. This is just for example. Then I have written this particular results here, and my target is to check whether the effectivity of all the vaccines are same or not. That means, what is my null hypothesis? X, Y, Z are equally effective. This is my null hypothesis. What is my alternate hypothesis here? X, Y, Z are not equally effective, right? So what we are doing here, we are actually performing rank. We are taking the global rank like the previous one. Okay, so after putting the global rank, now we are trying to perform this particular operations. We are trying to look at the calculation, H equals to 12 by n into n plus 1, like that. Okay, so n1 value is here, n1 equals to 5, n2 equals to 7, n3 equals to 6. R1 values are there, R1 equals 30.5. How I get 30.5? After addition of all R1 value. How I get the value of n1? Of n1 into n1, how many samples are there under this X shield? So these are the mentioned over here. If I put all the value in my H variable, then it will give me the result. That is H calculated, right? It's 4.25. And now I have to check what is the chi-square value of table chi-square value. It's 5.99. So chi-square value is high, so it's accepted. That effectivity of all the vaccines are same. So in this way, we can perform this test. Look at here. Here I have considered 3 data sets. That's why I have generated 3 data, right? Data 1, data 2, data 3. First, I have generated 3 data. Okay. So this is under this code. Actually, the line number 8, 9, 10 is here as 1, 2, 3. Okay. So if you start reading from here, look at here. What is the differences? Only I have passed here 3 arguments. So as I mentioned, that all the codes are differ by the name of the function and the number of argument I am passing. Very simple. I need to perform different statistical test. So I need to call different statistical test function. So the name should be changed. And every statistical test has its own significance, has its own work of function. So any statistical test can take 1 argument, 2 argument, or 3 argument. Here it's taking 3 arguments. So I'm passing 3 arguments. Very simple. So this is the code of Kruskal-Wallis. And this is the Friedman test. What is Friedman test? This is the another test. This is the alternate test for the two-way ANOVA test. First, this is the Kruskal-Wallis also the alternate of ANOVA, but it was for the one-way ANOVA, and this is for the two-way ANOVA test. Okay. So here, look at the formula. The formula is Fm equals to 12 by n into k into then k plus 1, like that. Okay. And degree of freedom is, what is the degree of freedom? It's denoted by nu, means number of samples minus 1. Now look at this example. In order to the following data represent the number of units of tablets production in thousands per day by 5 different technicians by using 3 different types of machines. So this is the examples. Technicians A, B, C, D, E. There are 5 different technicians. This is machine X, machine Y, machine Z, right? So they are actually producing the tablets. So what is the question? Conduct a Friedman test with the given data and judge whether there is any difference amongst the machines, or all the machines are same. Machine X, machine Y, machine Z's capabilities are same, right? So what will be my hypothesis? Same as previous, that X equals to Y equals to Z. But what will be my alternate hypothesis? X not equals to Y not equals to Z, right? And here also, in case of technician A, machine, this is, I have given the rank. Look at here. For the technician A, Machine A can produce 54 tablets, machine X can produce 54 tablets, machine Y can produce 48 tablets, machine Z can produce 57 tablets. So if I rank, then I can say that this is lower 48, so this is 1, then this is 2, this is 3, highest rank 3, okay, 57. So in this way, for each and every row, I need to put rank 1, 2, 3, or 2, 3, 1, or 3, 2, 1, 3, 2, 1, depending upon the number given here. Then I can add up. So this is 8, this is 7, right? In this way, I can add up. This is 15. This is my R value. Next, my formula demands R square. So I need to perform the R square. This is 64, 49, 225. So here, if I want to calculate this particular FM, then I can put all the values that I have calculated here, and I can get the value of FM. Calculated value as 7.6, 7.6. And the chi-square value, table chi-square value for the significance 0.05 is lower, so it cannot be accepted. We know that the calculated value should be less than the table value. So this is the code of Friedman test. Look this. Same like the previous, same. It also taking the 3 arguments, data 1, data 2, data 3, same arguments, 3 arguments, and here only the changes is the name of the functions. Here I have called here the class Fried machine square, and here also I have used the function Fried machine square, like that. So till now we have covered all the statistical testing, how it works, the function, the functions needed to calling that particular statistical test, and what is actually happening inside the statistical test by elaborate mathematical descriptions. Now, besides this statistical test, data visualization is also effective one. There are different data visualization tools. Look at here: pie chart, bar chart, histogram, Gantt chart, heat map, box and whisker plots. So different kinds of visualization tools are available in Matplotlib or maybe any other packages like Bokeh or Seaborn packages in Python, right? So, so you need to find out the inner meaning of your data. That's why there is a need of visualization of your data. Okay, so there are different tools out there. Look at here. So there are different tools. These are not a Python packages. These are different tools. In Microsoft Excel, you can generate chart. Google Charts is there. Power BI is there. Right? Tableau is there. So these are the different tools are there, right? And this is the data visualization with R. So if you're working with R, then you can also visualize your data by using different visualization tools. So this is the example of Titanic data. Okay. And now the thing is that now we have covered a lot of things, statistical testing, and then the data analytics part. But one thing is that what you need to accomplish. This should be the main question here. So if you do not have the clear goal, then you will not be able to find out the exact inner meaning of the insight of the data. So that's why first thing is that you should have the clear goal that what you want to do. Next, the mistake people made that they do not clean the data. So data cleaning is another very interesting steps. Next, visualize your data. So before writing any code, if you get the raw data, first visualize. Try to understand the data, whether it is scattered or not. Is there any outlier? That means, is there any impulse noise in your data or not? If there is an impulse noise or outlier present in your data, first of all, remove the outlier. That means filter your data. Then only you can put the data in any model using Python language. So next, relying on gut instincts. That means which model you are going to use. You need to decide that one. So being an expert, you need to decide that one. And then not considering the context. What does it mean? It's important to consider the context in which the data was collected. So this is the biased data. Suppose you have collected one data set and you are saying that my accuracy is 99%. But if I test your model with different data, your model accuracy is drastically false. How? Because the data you have gathered, that is biased one. For that particular data, your model is going to give you the very good result. But if I give you some other data, model will not be able to do that. This is called underfitting problem in data analysis using Python. This is called underfitting. This is actually, overfitting problem. What does it mean, overfitting problem? Means training data gives you better result, but testing data doesn't give you the better result. This is called overfitting. And underfitting means your training data don't give you the better result. Okay. Next is here, this data science. I have give you the essence of statistical testing, data analysis, and machine learning. Data science is actually the collection of all these things. Look at here. Machine learning, software development, traditional research. The intersection is data science. So these are the four pillars. You need to learn the mathematics. First of all, the statistics, probability, discrete mathematics, linear algebra, calculus. These are very much important. Then computer science background, programming background. Then the BI tools, data analysis tool, and the domain knowledge. The domain knowledge is very much important because what data you are right now selecting, whether are you cleaning the data or not. So data science is multidisciplinary. So here may be different, the participants may be from different backgrounds. So that's why for any background, you can use this particular tools, data science, for any kind of background. Because if you have data, you can use these particular tools. So this is basically whole data science value chain. Whole data science value chain. This is a complete scenario of a data science. Starting from where and ending where. Look at here. You can be able to find out each and every term of this data science, data analytics, Python, everything. Machine learning, statistical analysis, forecasting, text analysis, deep learning, everything. Look at here. Data ingest, data engineering, enrich data, data science. This is the cycle. Okay. So these are the different applications where presently Python are used with the emerging technologies in data analytics, AI, big data analytics, robotics, IoT means Internet of Things, or IoMT, Internet of Medical Things, or industrial Internet of Things like Industry 4.0. Here all we are using Pythons right now. Okay, and we are assuming that data science in year 2050, what will happen? A lot can change in 30 years. Okay, so billion of sensors have been collecting data for decades. So lot of data can be collected, and if we have lot of data, then we can use that data for scientific discovery, private organization, and civil society. Okay. So these are the things. Now people are using Twitter, social media accounts. So these are the digital humanities on Twitter, right? So this is the another analysis using Python and machine learning tools. And this is the for the private organizations, that how much profit you want to book. Next, this is also for Spotify applications. So for the civil society. So these are the different healthcare applications are there. These are the future. These are the future. So here I would like to mention that whenever you are learning the statistics, you need to learn this machine learning also in later. And here supervised learning, unsupervised learning, reinforcement learning, all are under the statistical learning tools. So machine learning is basically statistical learning tools. Look at here, the classification, regression, clustering, all are machine learning techniques, right? So what you are doing, the same thing, as I told you, in case of statistical test, we know how the test is actually performed because we know the mathematics. And in case of Python programming, what we are doing, we are calling the function. Here also is the same thing. If you know how logistic regression will perform, then you are aware of that technique. When you are writing your Python code, you just call logistic regression function, right? Here you have used stat as a package for using the statistical test tools. In case of machine learning, you can use different packages. One of the example of most popular machine learning package is scikit-learn package. You can use scikit-learn package here, right? For machine learning operations. So this is the diagram of the flow of machine learning. And now this is the statistical tools again, linear regression. We all know that. So if I draw a graph and if I get an idea that what is the relationship between these particular attributes, is linearly correlate or not? So is linear regression, logistic regression, all are the statistical tools. You can use that tools for statistical analysis using Python. Now, finally, we are actually end of my lecture. So here, before ending the lecture, I again want to start my lecture by saying that data is very much important. Testing is the last phase. But if your data is not fitted properly, then how you can think that your testing will give you the better result? So data is the very much essential here. That's why here written is that data are varied. If you collect one data, same from same location, you will write the data or you will collect the data using your own technique. I will collect the data using my own technique. So that's why man to man, people to people, the data collection may vary. So some amount of preparation is always needed before collecting the data. That is why we are saying that which kind of tools we need to follow. Look at here, prediction tools, model summaries, figures and reports, which inform understanding and decision making. That means after gathering the data, what you need to perform, why you are gathering the data, what is your motive? You are trying to predict, you are trying to construct one model, or trying to generate some figures or reports, right? So there should be some walkthrough. So if you just got a data set, then you need to understand what are the variables, manage your columns, and the most important thing is that, is there any missing value in your data set? What do you mean by missing value? In case of real data set, there may be a lot of missing value, lot of value that may be corrupted or missing value. No values are there. So how will you work with that missing value? So there should be a technique that how to eliminate the missing value. So if you think that you will just eliminate the row, you just delete the row, then you will end up with less number of rows. Your Python model, your Python programming model, that means the machine learning model or the deep learning model, data analysis will perform or will give you better accuracy, will perform better job when it will have the opportunity, it will have the opportunity to work with huge amount of data. But if you eliminate the missing data, then actually you are reducing your data. So the technique is not to reduce the data. Technique is not to eliminate the missing data, but technique is that eliminate the missing, replace the missing value with the mean value of that particular column. Suppose some of the pupils' age value is missing. What I need to do? I need to calculate the average value of that column and I need to put that value. In this way, I can handle the misvalue problem. Okay. So you need to able to know the data dictionary. Data dictionary means how many columns are there, name of the columns, type of the data, how many data you can save there. So these are the information you need to find out. Okay. Then managing data types. Are you working with date types? Date has a different types. Number has a different type. Time has a different type. So which kind of type you are using, right? So you need to take all this into account. And again, if you work with categorical data, think of the situation. You need to perform statistical test on categorical data. Your data set is actually categorical data. When you're trying to predict something, then how will you perform the operation on categorical data? You need to convert your categorical data into the numeric data. So there should be a function, there should be a way to convert the categorical or string type of data, that means the sentence type of data. Today is very hot. So this very hot, how will you convert this very odd to a numeric number, right? So this is the way how to convert all these things. Suppose I'm talking about India, Sri Lanka, maybe USA, UK. So these are the name of some countries. So how will you work with this name? So you need to convert this to the number. Suppose I have given India 1, Sri Lanka 2, UK 3, USA 4. Now I can work with 1, 2, 3, 4. So this is the conversion of string to numeric, means categorical data to the numeric data. So when you got the data set, first of all, you need to check that is there any categorical data present in my data set? If the answer is yes, the next check is that whether I'm using that particular particular column for my prediction, for my analysis. If no, then leave it. If yes, then convert it to the numerical one, right? So in this way, check for the missing value, check for the categorical data. This is the process of data filtering. You are trying to filter your data before writing the program, okay? So these are the different, so this is the missing value problem I have told you. And then in this way, what you can do, you can perform after that feature engineering. Feature engineering means what you need to perform. Look at here. Feature engineering means you have analyzed your data, 10% of data you have analyzed. Look at the total scenario of feature engineering. What are the functions you are performing? You are performing analysis 10%. Look at here, data cleaning 20%. Feature engineering 25%. Algorithm selection, what algorithm to use, means what model to use, what statistical model to be used, is 10%. Model training is 15% and other is 20%. So here feature engineering and data cleaning is very much important. Now the question is here, what we are doing in feature engineering part? That means the feature selection. When you are analyzing any data, try to find out what is the actual attribute or the most important attribute. Suppose if I am talking about the heart attack of a patient, then if I think of that, some of the attributes are given to me. That means some of the features are given to me. Features look like blood pressure, cholesterol, height, weight, vegetarian, non-vegetarian. So these are the different features are there. And the last column is the dependent column, maybe heart attack or no heart attack. These are the different two options are there. Then first of all, I need to understand whether I need to consider all the columns to calculate or to predict or to analyze whether a particular patient will have a heart attack or not. Or here, maybe the vegetarian or non-vegetarian, these columns has no effect with the heart attack. So I can eliminate the column. So in this way, I need to select the best feature by eliminating the unused or the low significant features. This is called feature selection. If you properly choose the exact features, then your accuracy will go, your sensitivity will grow, your precision will grow, right? And you will end up with good statistical result. So to get the good statistical result, you need to follow the basics or primary steps very sensitively. Otherwise, you will end up with average result or the result that is not accepted in machine learning. Okay, so these are the things that I have covered today, and that's why I'm saying that here lot of cases, that is, these are the outlier detection. I have told you already about what is outlier. So I think this will help you to gather complete knowledge about data pre-processing and data analysis and then statistical test. Okay, so I think right now I should end here, and if you have any question, you can ask me.